It's time to turn our attention to the last of the planets visible to the naked eye in the vast expanse of our solar system, the majestic Saturn. Second only to Jupiter in size, Saturn presents a remarkable paradox. It is the least dense of all the planets. If you could find a bathtub large enough to hold this gaseous giant, Saturn would effortlessly float on the surface, leaving behind only its distinctive ring-shaped wake. Saturn's buoyancy stems from its gaseous composition, which implies an extremely low average density. Scientists believe its core consists of rocky material several times more massive than Earth, surrounded by layers of ice and metallic hydrogen. Above this lies a deep atmosphere composed mostly of hydrogen, with smaller amounts of helium, methane, and ammonia. Although 2/3 of Saturn's density is equivalent to that of water, the planet wouldn't sink, not because it's lighter than water in an absolute sense, but because its immense gravity would pull any hypothetical bathtub's water toward itself. Of course, if the bathtub were truly Saturn-sized, its mass would surpass the planet's, and the water would pull Saturn down instead. Astronomy is full of such fascinating thought experiments. Saturn spins at an astonishing rate. Its day lasts just over 10.5 hours. This rapid rotation, combined with its low density, causes the planet to bulge noticeably at the equator, making it about 10% wider there than at the poles. This flattening is clearly visible through a telescope. What we see of Saturn are the tops of clouds made of ammonia ice, beneath which lie deeper layers of water clouds. Like Jupiter, Saturn's atmosphere is relatively stable, though it appears more muted in color, likely due to its greater distance from the Sun, resulting in lower temperatures, and its deeper, more diffuse cloud layers. Despite its calm appearance, Saturn is not devoid of dramatic weather. Occasionally, massive storms erupt across its surface. In 2010, an amateur astronomer spotted a colossal tempest in Saturn's northern hemisphere, later captured in stunning detail by NASA's Cassini spacecraft. This storm encircled the entire planet and left atmospheric effects that lingered for years. One of Saturn's most striking features is the persistent hexagonal vortex at its north pole, a phenomenon also seen on Earth, but on Saturn it reaches truly colossal proportions. This six-sided jet stream forms due to the complex interaction of rotating atmospheric flows within the spinning planet. It spans about 20,000 kilometers, wider than Earth itself. Above this hexagon, a massive hurricane rages, extending 2,000 kilometers across, with wind speeds reaching 500 kilometers per hour. Yet Saturn's most iconic feature is undoubtedly its magnificent ring system. Galileo first observed Saturn's rings in 1610, but his telescope wasn't powerful enough to resolve them clearly, leading him to mistakenly believe Saturn was a triple-bodied object. Decades later, the Dutch astronomer Christian Huygens correctly identified them as a thin, flat ring encircling the planet. Had the rings been solid, they would have torn apart. Because the inner portions orbit faster than the outer ones, a solid structure would be ripped to pieces by differential rotation. In reality, Saturn's rings are made of countless tiny particles of nearly pure water ice, each orbiting the planet independently. Saturn holds the record for the most moons in the solar system, and its rings are astonishingly vast, stretching over 250,000 kilometers across, covering 2/3 the distance from Earth to the Moon. Yet they are incredibly thin, no more than 10 meters thick. To put that in perspective, if Saturn were scaled down to the size of a sheet of paper, the paper would still be 10,000 times thicker than the rings. Why are the rings so flat? Their origin remains uncertain, but two leading theories exist. One suggests a former icy moon was shattered by a massive collision, scattering debris into orbit around Saturn. Over time, collisions between these fragments flattened their orbits into a disk. Another theory proposes that a large moon once spiraled too close to Saturn. Its rocky core sank toward the planet while its icy outer layers were stripped away, forming the rings. In either case, Saturn's equatorial bulge helps confine the rings to the planet's midplane through gravitational effects. There are three main rings, labeled A, B, and C, in order of discovery. Ring B is the brightest and widest, spanning about 26,000 kilometers. Ring A lies just outside it, while the fainter Ring C is nestled inside Ring B. Early astronomers thought rings A and B were a single structure, until Giovanni Cassini discovered a dark gap between them in 1675. Now known as the Cassini Division, this 4,800-kilometer wide gap isn't empty. It contains several faint ringlets. The gap is maintained by gravitational resonance with Saturn's moon Mimas. Particles in the gap orbit Saturn twice for every single orbit of Mimas, and Mimas's gravity tugs them out of that region over time. Other moons have carved additional gaps in the rings. Within the main rings lie hundreds of fine ringlets. Just beyond Ring A lies the narrow, braided F ring, shepherded by two small moons, Prometheus on the inside and Pandora on the outside. Their gravitational pulls confine the ring particles, keeping them tightly aligned. As these moons orbit on slightly inclined paths, they generate towering vertical waves in the rings, some reaching several kilometers in height. Yes, several kilometers. Saturn's moons are just as extraordinary as its rings. Take Mimas, for example. Not only did its gravity help carve the Cassini Division, but it also bears a massive impact crater that makes it resemble the Death Star from Star Wars. But two of Saturn's moons stand out as particularly compelling: Titan and Enceladus. Titan is a true giant, larger than Mercury and only slightly smaller than Mars, second only to Jupiter's Ganymede among moons. It's the only moon in the solar system with a substantial atmosphere, 4 times denser than Earth's, though it's composed mostly of nitrogen, with traces of methane and hydrogen. Surface temperatures plunge to minus 180 degrees Celsius, far too cold for liquid water. A thick orange haze obscures the surface in visible light. But the Cassini spacecraft, which orbited Saturn from 2004 to 2017, used radar and infrared imaging to map Titan's terrain in detail. In 2005, Cassini deployed the Huygens probe, the first and only landing on a moon beyond Earth, which revealed a surprisingly Earth-like landscape. Dunes made not of sand, but of hydrocarbon grains. Cryovolcanoes erupting water instead of lava, and river channels carved by flowing liquid. Gravity measurements strongly suggest a global subsurface ocean of liquid water beneath Titan's icy crust. Most astonishingly, Cassini discovered lakes and seas of liquid methane near Titan's poles, the first confirmed bodies of surface liquid beyond Earth. These methane lakes change shape over time, indicating an active methanological cycle analogous to Earth's water cycle. Combined with its thick atmosphere, organic molecules, and potential subsurface ocean, Titan has become one of the most promising places in the solar system to search for life. Though whether life actually exists there remains unknown. Enceladus, another icy moon about 500 kilometers wide, roughly the size of Colorado or southern England, is equally intriguing. It's one of the most reflective objects in the solar system, covered in freshwater ice. Its surface shows a mix of ancient cratered terrain and smooth plains, suggesting a dramatic resurfacing event in its past. Like Jupiter's moon Europa, Enceladus is crisscrossed by fractures, especially near its south pole, where Cassini discovered spectacular geysers in 2005. These tiger stripe fissures spew water vapor and ice grains hundreds of kilometers into space, fed by a global subsurface ocean kept liquid by tidal heating from Saturn's gravity. Cassini even flew through these plumes and detected organic molecules, key ingredients for life. While we don't yet know if life exists on Enceladus, it, along with Europa and Titan, is now considered one of the top candidates in the search for extraterrestrial life. Remarkably, scientists once focused only on Earth-like planets, but now, cold, icy moons have emerged as perhaps the most promising abodes for life. Saturn has over 60 confirmed moons, each with its own quirks. Iapetus looks like a walnut, wrapped around its equator by a mysterious mountain range whose origin baffles scientists. Hyperion resembles a porous, sponge-like chunk of cork, so lightweight it might float in water. Many of Saturn's outer moons orbit in the opposite direction of the planet's rotation, likely captured asteroids or Kuiper Belt objects, icy relics from the solar system's formation. Ask any astronomer or astronaut what first inspired their passion for space, and many will point to the moment they saw Saturn through a telescope. The author shares this experience. As a child, his parents set up a modest telescope in the backyard, aimed it at Saturn, and revealed a breathtaking sight. Rings so delicate and perfect they seemed unreal. To this day, he finds immense joy in watching others see Saturn for the first time, calling it one of life's greatest pleasures. Saturn is truly a wonder, a planet of stunning beauty and profound scientific intrigue. Today, you've learned that it's a gas giant with rings made of icy particles, sculpted by the gravity of its many moons. Among them, Titan, Mercury-sized, with a thick atmosphere and methane lakes, and Enceladus, with its hidden ocean and erupting plumes, may even harbor life. While that remains unproven, the possibility makes Saturn not just a jewel of the night sky, but a beacon in our search for life beyond Earth. This episode of Crash Course Astronomy was produced in collaboration with PBS Digital Studios. Be sure to check out their channel for more incredible science content. Written by Phil Plait, edited by Blake DiPastino, with Dr. Michelle Fowler as our science advisor. Directed by Nicholas Jenkins, edited by Nicole Sweeney, and featuring graphics by Thought Cafe.